Integral test. This is a test that can be used to determine if a series converges or diverges. Now, if you have a series, right? A series is adding up a number of terms, right? Well, when integrals, the concept behind an integral is adding up an infinite number of infinitely small rectangles. So the concept behind both, and we're going to get maybe a little more precise with these until we get to our dx's. So we're adding up infinite number of infinitely small rectangles. So almost like all this, each of these is a rectangle. So essentially what we're doing with integration is very similar to what we're doing with series, just on a much more specific scale. So if we have the sum n equals 1 to infinity of something like 1 over n plus 3. Well, a way to tell if this is going to converge or diverge is to integrate it. And if the integral, the behavior of the series is going to follow the behavior of the integral. So if you integrate it from 1 to infinity, 1 over n plus 3, if this converges, the series will converge. If this diverges, the series is going to diverge. So we could also write this as the limit as a approaches infinity, integral of 1 to a over 1 plus 1 over n plus 3. This is just the integral of, well, this is a u is going to be equal to n plus 3. But since du and all that's just going to be equal to 1, we could just, and this is going to end up as a 1 over u, we can just write the limit as a approaches infinity of ln n plus 3. Because that's what we're going to end up with. And it is from 1 to a. Now, from here, if we do the limit as a approaches infinity, and we do ln of a plus 3 minus ln of 1 plus 3, which is 4. Well, if we plug in infinity for a, we get ln of infinity plus 3 minus ln 4. Now, this number is going to go into infinity, and we're subtracting whatever ln of 4 is. But it doesn't matter because this is a whole number, and we're subtracting it from infinity. This integral is going to diverge, which means the series would also diverge.